This podcast is brought to you by Toyn. Since 1942, Toyn has been building high-quality fire apparatus with a wide range of options that are customized for your unique needs. Toyn is built to take the call. To learn more, visit www.toyn.com. Hi, Chris McClune here with Fire Apparatus and Emergency Equipment. Welcome to this episode of our podcast. It's going to be a moving water podcast today. And again, my water delivery folks here are Andy Sacadato and Bill Adkins. And we're going to talk about fill sites. Again, coming from the rural side of this, we're going to talk about some things that help make a successful operation there. Maybe some equipment that maybe they've seen that you haven't yet that's worth taking a look at, and talking about the different type of hoses that we're using to supply these fill sites. So Bill and Andy, thank you very much again. Andy, I'm going to start with you and start off with what are the pillars of successful fill site operations?
Yeah, absolutely. Thanks for having us again. It's a pleasure to be here. But when we're talking about successful fill site operations, it's really important to understand there are a couple key things that are going to dictate whether the operation is going to be successful or not. The first one that I consider is equipment. Do you have the equipment available to you in order to perform an effective fill operation? The next one is whether or not you have the manpower in order to pull off an effective fill operation. Typically, that's going to be at least one engine company's worth of folks, usually 3 to 4 people, depending on the type of fill operation that you're doing. And then lastly, do you have the training to be proficient with fill operations, and have you pre-planned your fill sites in the rural setting in order to be efficient when it's time to actually do a fill operation in that rural setting?
Bill, how about you? Anything that Andy didn't mention?
As far as when it comes to pillars, we like to make sure we pre-plan. We know those sites beforehand. It's not something you want to just shoot at the hip unless it's like you're at some farm or so that has a pond that you didn't know about. That'd be the only time we're going to have where we don't have some type of pre-plan of those sites. And like Andy mentioned, equipment, not only equipment for your department, but your mutual aid companies. Whenever we're dealing with these rural water movement stuff, we have to heavily rely on our mutual aid companies. So I know in my area, we don't have this much of a problem, but if you have different threads from neighboring departments, you need to make sure you have those adapters. You can't always rely on those companies to bring their own. So having those pieces there, and we want to always try to find a site that can sustain at least 1,000 gallons a minute. That's some of the pillars that I look for when I'm finding a site and setting up a fill site.
One of the things you brought up there was mutual aid, and I want to look at it from a slightly different perspective in that you could have, we're always talking from the rural perspective, but you could have, you could have a district that one half of it has some really decent hydrants. The other half of it is not hydranted for whatever reason, and you're going to have to rely on something like this. So you would be also looking at, maybe not necessarily tankers or tenders, but, like Andy was saying, engine companies set up for, structural firefighting, not necessarily getting into a fill site type of operation. So very, very important also to think, I know that we're always talking from the rural perspective here, but, you could, as a more suburban company, find yourself either by virtue of it being your own district or by virtue of it just going just crossing the street over the township line to the other side, where you're going to be expected to fill some of these roles. We have a question coming up later about if that fill site is a hydrant, and so just another important aspect of this where when we think about fill sites, it doesn't necessarily all have to be for lack of a better term in the boonies. It could be just across the road to another municipality that doesn't have a lot of hydrants or does not have a good source of municipal water.
Well, I'm glad you bring that up, Chris. Right, because something that I like to remind folks too. A lot of urban fire departments think that they'll never have to do any rural water work, but there have been plenty instances across the United States where urban municipalities have had large scale fires where they have to supplement their municipal water system with rural water tactics. So just because you're in an urban environment doesn't necessarily mean that you will never have to implement some of these fill site or rural water tactics at all.
That's true. We have one in my county. I would say within the past 5 years, we had it where the municipal water source was tapped out. The towers were dry, and they had to establish a whole new water supply using just tankers and wherever. I don't remember where the fill site was. We've got some decent rivers that flow through here, so I think this one was near either a river or a pretty decent sized creek. And exactly that. If your municipal water system is compromised somehow, you need to look in a different direction.
Yeah, I've had that experience myself. We had a fire, and the building was so big and required so much water that even though we had a hydrant right there in the front yard, we were using that hydrant to fill multiple dump tanks because the main wasn't large enough to sustain the flow that we needed on the fire ground. So we were using dump tanks from tankers coming from across town, dumping their water along with the hydrant itself flowing into those dump tanks or the intake as well.
Well, I want to talk a little bit about the hose lines that we're using for these fill sites, and when we were talking about when we were talking about potential topics down the road for this podcast, this is one that came up, and this one started with the idea of medium diameter hose and large diameter hose being used for fill sites. So I guess to get us started on that, Bill, when you talk about medium diameter hose and large diameter hose, is there a range of hose that fits into each designation? For large diameter, are we only talking 5-inch and up, or is it 4 to 6 inch, and then medium diameter gets into a different range? What is there a range of sizes that exist within each category?
Well, the range in our area is 4-inch or above, as what we consider LDH. We have a lot of people that have the 4-inch hose with 5-inch Storks fittings, but we consider the medium diameter hose to be that 3-inch, 2.5, and 2.5. That's what we usually use for our supply line, and it's all based on what flows you're going to need at that particular fire. Your room and contents fire, maybe you don't need to set down LDH. You can do that with the 3-inch. I'm a large. I have a component of using 3-inch instead of 2.5 for the less friction and more flow that you can get through the 3-inch than you can the 2.5. But you don't always have to lay 5-inch for every fire you go to. However, if you feel that if this fire may be starting off small and becoming large, you always, I would want to use the 5-inch just in case it does become larger.
Any, how about you? Any particular ranges that you feel, not only, with when you were on the department and with the training that you do now?
Yeah, from a definition standpoint, most people will consider medium diameter hose to be your 2.5, 3-inch, and 3.5-inch supply lines, with your large diameter hose being your 4-inch, 4.5, 5-inch, and 6-inch. But really, it just depends on your locality and what you prefer to use. The use of large diameter hose versus medium diameter hose for fill operations is a hot topic in a lot of places, depending on where you go, right? Some people are very adamant that they're using large diameter hose because of the fill flow rates that you're able to get, while other people are adamant about using medium diameter hose because it's more maneuverable. What I like to tell folks is, you have to do whatever works for your organization, and especially when it comes to filling tankers at a fill site, right? Hydraulically speaking, when I use multiple medium diameter hose lines, I can get the same flow as a single large diameter hose line. So the question becomes, which type of hose is going to give me more efficiency when it comes to the making and the breaking times of the fill operation? I've been a part of some fill operations where departments and organizations are using 4 and 5 inch hose connected directly to a direct fill on a tanker. And yeah, the 5-inch hose will flow 1,000 gallons a minute with minimal friction loss. But then because of the weight of the water in the hose, once the tank is full, you see a lot of people wasting time trying to muscle and break the connection because of the water weight in the supply line. So actually, from an efficiency standpoint, they lose efficiency, even though they were very efficient on the fill side of things. Whereas, we've replicated the same scenario and in the same training event by simply replacing the large diameter hose with 2 medium diameter hose lines going into 2 direct fills on the tanker. And hydraulically, they fill at the same rate because I'm splitting the total flow between the 2 lines. So I'm able to still flow and fill my 1,000 gallon per minute tanker rate that I want. But when it comes time to break the connections, it's much easier to break the medium diameter hose from the truck, and therefore it increases the efficiency of the operation. But again, here's the thing to think about, right? Manpower is a big part of this. So if I have 2 medium diameter hose lines that I have to make the connection to on the back of the tanker, well, ideally, I need 2 people to make those connections. So do you have 2 people to make and break? If you only have 1 person to make and break, you have to time it. Is it going to be more efficient to do 1 large diameter hose and come up with good options for draining the water so that way you can break the 5-inch easily or 4-inch easily? Or is 3-inch or 2.5 dual medium diameter lines sufficient for your operation?
Now, when what you've described on the medium diameter side, kind of gets into some of the hose that's being designed and manufactured today, and probably a bit on the LDH side as well, though I don't know if it matters as much. But we see a variety of internal diameters on these different size lines. Probably, when we get down into, the attack line is when we're really probably paying the most attention to it. And so that's kind of where this question is coming from, because, you mentioned you want to do this quickly. You want to do it efficiently. And whether that's 2 medium diameter lines instead of 1 large diameter line, it's whatever's going to do the job, as quickly as possible, but also efficiently. Do we need, regardless of all that, whenever we're talking about this size line, whether it's the medium or the large, do we need to worry about the friction loss, or is it? I guess I shouldn't say do we need to worry about it, because it's always kind of on our minds, but especially on the large diameter side, the friction loss is usually negligible. It's when you start to narrow the size of the line that it becomes an issue. But because of what we're doing here, and because the flow rates are already pretty high, do we need to worry about? Is that something that, if a department's looking into this and trying to make that decision between which size line to go with for their SOPs, is that something that they need to worry about? Bill, is friction loss something that we really need to be, getting granular with, beyond just realizing that it's there and it might impact a little bit of the flow?
Right. Yeah. As far as that goes with us, we don't consider the friction loss that much, because we're not using very much MDH, medium diameter hose. We will usually lay down the large diameter hose, which is roughly, we'll say 5 pounds per 100 feet or so. And then we use either a manifold or a gate valve to branch off into those 2 medium diameter hose. And so the friction loss there is not much, because we're using such short sections of that medium diameter hose. So yeah, we don't really consider much of the friction loss as long as we're flowing around that 1,000 gallons a minute.
Okay. Andy, what about you? Like when you're teaching, does that come into play much, or are you pretty much aligned with what Bill was saying there?
So what I'll say is, I'm a dork, so I'm always thinking about friction loss and always doing the math. But to answer that, what I'd like to say is, in my mind, there are two basic configurations for my fill site in my mind, and I like to keep it pretty broad. So option one is something that I call a pumper controlled fill site. So that's a scenario where my fill site pumper is close to the water source that we're using, and the tankers are able to come directly right there where that fill site engine is to get refilled. So generally speaking, like Bill said, hose lengths aren't that big a deal, right? Hose runs are going to be short. And if I'm using large diameter hose, right, we're looking at, if it's 4-inch hose, it's only 20 pounds per 100 foot of friction loss. If it's 5-inch hose, it's, if you do the coefficient method, it's about 8 pounds. I round up to 10 pounds per 100. So the friction is pretty negligible in those short runs. Now, in those instances, depending on the configuration and stuff like that, I may elect, rather than using the large diameter hose, I may use dual medium diameter hose because of how my discharges are configured on my truck. So in that scenario, if I'm using dual 3-inch lines, what I want to remember is that I have to split the flow in each line. So that's 500 a piece. And that, again, is going to be 20 pounds per 100 foot. So again, not terrible. The 2.5 is where you really do need to do the math, because in 2.5-inch hose at 500 gallons a minute, and I would urge anybody, if you're using and filling with 2.5-inch hose or 3-inch hose for that matter, if you're doing medium diameter hose, you got to be hooking duals to your truck, right? That is the only way that you're going to increase the efficiency of your fill operation. But with 2.5, especially, if I'm using dual lines to fill my tanker, that would be 500 gallons a minute apiece, and friction loss wise, that's 50 pounds per 100 foot. So that becomes a big deal. 2.5, right, is really on that edge of, is it efficient for these fill operations, or is it a better large caliber attack line in a lot of fire departments? But that's your pumper controlled fill site, and you can kind of get away with either or. The other option is kind of what Bill alluded to, and it's what I call a manifold controlled fill site. So here's a scenario where my water source is down some narrow pig path road or whatever, and it makes more sense for my fill site engine to go to that site, but lay a supply line to a manifold or a water thief or something up at the main road where the tankers can come and get filled. So in those scenarios, depending on the lay, right, I really want to be laying large diameter hose, because at 1,000 gallons a minute, especially if I'm using 4-inch, that friction loss gets up there very quickly. So, if I do 1,000 gallons a minute and it's a 500-foot lay in 4-inch hose, that's 100 pounds of loss right there. Then I got to add appliance loss in the manifold. Then I got to do the friction loss in the lines coming off the manifold to fill the tanker. And then I want to make sure I give about 20 pounds going into the back of the tanker, just to overcome any loss that may be in the valves, the direct fill valves themselves. So in those scenarios, that's where LDH is really, really important. And essentially in that configuration, that manifold controlled operation, all you're doing is you're putting the pumper at the source, and you're moving the pump panel up the street to where the tankers can be filled. So that manifold becomes a remote pump panel from the pumper that's operating at the fill site.
So we've talked a bit about medium diameter and large diameter. Is there anything else anyone needs to be considering when choosing between the two? And are there other types of hose that can or should be considered for fill sites? Andy, I'll start with you on that one.
I would say that from a hose perspective, you need to use whatever your department A carries, and B works for your department based on the manpower and the other things that we talked about. But here's the one thing that you can do to like up your make and break times, whether you're, especially if you're using medium diameter hose. Consider not using threaded connections, right? Now, what I'm saying here is I don't expect a fire department that purchases 3-inch medium diameter hose not to have national standard threads, right? But if you're doing a fill operation, it's advantageous to get Storts adapters for the 3-inch hose or 2.5-inch hose to kind of speed up the make and break times for your fill operation. Some localities will use cam locks, the 2 cam locks, kind of like what the fuel industry uses. I can tell you, and I might get a little heat from this, I'm not a fan of the cam locks, only because they are very quick, and you can make connections very quickly. You can break connections very quickly. But I've also seen people break those connections under pressure and have those lines blow off under pressure. I know of an instance where a guy broke every bone in his hand because he, broke the connection while it was still pressurized, and that thing launched off and shattered his hand. So those scare me a little bit. If your organization is using them, that's fine, but I think you need to. My advice would be to be a little bit more diligent on the training and make sure that everybody understands that you do not touch that coupling unless you feel that hose is limp and there's no pressure behind it, because it will kill you if given the right circumstances. That's kind of why I like the Storts fittings, because even pressurized, it's very hard for me to with my hands, break that connection. So I usually, if it's hard to break, I have to get wrenches to break it. And usually if I'm getting wrenches, that gives me enough time to say, all right, is this because there's pressure on it, or is it a tight gasket or something like that? So I like the Storts fittings more than the cam locks personally. But just understand that you can get those Storts fittings. I know departments will get them in like 3-inch Storts fittings just for fill operations.
Bill, any comments on that?
Yeah, I agree with Andy wholeheartedly on that. I've seen the cam locks fail. Your firefighter thinks they have them connected right, and then it slips off somehow and under pressure. I'm also with Andy as far as I wouldn't tell a department to go buy a bunch of hose that's got Storts fittings if they don't have it in their budget. Everybody has national standard for the most part, or some type of thread. But if you're wanting to make things just that few seconds faster, yeah, the Storts fitting is definitely more efficient. Not all hoses is the same. Just because you're buying 2.5 and 2.5, I try not to mix match any hose. Use the same brand. Use this, so that your flows are what are correct of what you've set your pressures to be.
One thing I want to add with the cam locks, one application that I really do like the cam locks for is drafting. I know some departments will put the cam lock fittings on their 6-inch hard sleeve, and that rapidly reduces the time it takes to put multiple sections of hard sleeve together to get into the static source. So that's one really good use, and obviously it's advantageous. I don't have to worry about things blowing off because we're operating in a vacuum there. I just get a little hesitant in the pressurized world with those cam lock fittings.
I agree.
Now, like I said, the idea for this podcast started off with the focus on medium diameter and large diameter hose for fill sites, but we are going to transition a little bit out of the hose line part of this and get into equipment. But before I get full bore into the equipment side, just you've alluded to it a few times in your answers, Andy, when you've talked about the fill site engine. And so, is there merit to assigning a fill site engine to the fill site, even when that source is a hydrant?
In my perfect world, yes. If I were king of the world and could make every fire department the way it is, the way I want it, right, I would always assign and make my run assignments so that way I have an engine that's going to serve as nothing but a fill site pumper. That kind of goes without saying when I'm dealing with a static source because, I need a pumper of some sort to pump and fill the tanker, unless, of course, I'm using a vacuum tanker, and we'll talk about those later. But, if we're using traditional pumpers and traditional gravity fed tankers, right, I definitely need a fill side engine to draft that water and fill the truck. And even if I'm running pumper tankers, it is usually not too super efficient for that pumper tanker, if it's in the shuttle route, to pull up, assemble its hard sleeve, get a draft, refill itself, break all that down, and then leave, and then let the next pumper tanker do the same thing. It's way more efficient just to assign one engine to do all that drafting and do all that filling, and those tankers can just fall in line and get filled and rock on. But where I see a lot of people avoid the fill site engine assignment is when the water source is a fire hydrant, because they think that, well, the fire hydrant, I don't need a pumper because it's pressurized and it'll fill the truck. And that's true. But the thing that you need to remember is that fire hydrants are designed to deliver volume, and they're not designed to overcome friction in hose. So I can have a hydrant that is capable of delivering 1,000 gallons a minute, but if it doesn't have the residual pressure to flow 1,000 gallons a minute and overcome the friction loss in whatever supply line that I'm connected to, right, then I ultimately do not fill my tanker at that 1,000 gallon per minute flow. Therefore, it sits at my fill site longer, and then efficiency drops off pretty dramatically. Even if that hydrant, so some folks, like the volunteer department that I ran with in Virginia, we were running 4-inch hose for our fill connections. So even if I'm using 4-inch off of that hydrant to refill the tanker, and let's say the hydrant's on steroids, it has volume and pressure, there's still some time that's lost because the tanker driver has to do what? They got to position, they got to make the connection, they got to turn the hydrant on, they got to fill the truck's got to get filled, they got to shut down the valve on the hydrant. Hopefully they have a hydrant gate valve on the steamer port to shut down that, and they don't have to shut the hydrant all the way down. But then they got to break the connection, they got to move, they got to get back in the truck, and then they got to leave. So even that, it still adds a lot of time to the operation. Whereas if I put a pumper on that hydrant, right, now I use that pumper and that pump panel and the valves there to go ahead and do the filling. I can let my tanker drivers do what they're supposed to do and stay in the truck, right? The tanker driver should stay in that truck. And then we fill the rig. Once it's full, we break and it bounces. I like to tell my students that tanker fill site operations is the closest to NASCAR that you're going to get in the fire service, because it's a NASCAR pit stop, right? That's the closest we're going to get. We want to be efficient.
Bill, how about you? Realistic for your operations on the rural side?
Yes, it is. Even a good hydrant in the rural setting is not a good hydrant, for most fires. Because our hydrants are so poor in this area, we will set up dump tanks and have that hydrant constantly flow into those dump tanks so that there's no downtime. They continuously flow 1 or 2 dump tanks, and when the tanker shows up, the engine will draft out of those dump tanks and fill those tankers as they show up. If we were to hook that hydrant up, even if we used a 25-foot section of hose, that hydrant wouldn't flow enough to sustain that 1,000 gallons a minute in this area. So now, don't get me wrong, if it's a smaller fire, room and content, we won't necessarily need to put an engine on that hydrant. But if it's a larger fire where we're going to be on there for a while, we will, and we need that larger volumes of water on the fire ground, we'll set up a engine on the hydrant and have that water ready. We have a lot of fill hydrants, what they call fill hydrants, was those 2.5-inch hydrants in our area. And, we want to pass one up and go 5 miles further to get to the hydrant. We'll use those. But those fill hydrants, those are great examples of us hooking up to them and have that water continuously run into a dump tank so that we can draft that water out.
Yeah, that's perfect. I love that tactic personally. And all I was going to say was, departments that I have been involved with and talked with, and seen, successful fill and rural water operations, they've worked to where their mutual aid or their basic run assignments, they're calling for at least 5 engines on a rural fire. And I know for some areas of the United States, that's a lot of resources. So I implore you to work with your mutual aid partners to see what has to happen to get those types of resources. I know it might not be realistic for everybody, but the organization that I was a part of, the idea was the 5 engines had a role. The first engine was going to be the primary attack piece. The second engine was going to go ahead, depending on the driveway length, they may lay up the driveway and booster back to the initial attack engine. Your third engine is responsible for the dump site, and your fourth engine is kind of your pivot at the fire scene. They can be a transfer engine. They could just hang out. Their crew may go and be writ or whatever you need. But always that fifth engine, that last arriving engine, the rig that was always going to be the one that's the furthest out, was the fill side engine. And they knew from the initial dispatch, hey, we're fifth due. We're going to be the last ones to show up to the party. So rather than go to the fire scene, our company, we're just going right to wherever our fill site is, and we're going to set up that fill site.
Now, we've already talked about equipment, whether we think we have or not. I mean, we talked about the hose, we were talking about fittings, we were talking about some manifolds. But what other, that's been, one aspect of this, but what other equipment that maybe people aren't thinking of all the time is essential for fill sites? Andy, I'll start with you.
Yeah, I would say the biggest thing, especially if you're, in a very rural organization, right? Hard sleeve's the biggest. You hear it all the time whenever we're talking rural stuff. I harp on hard sleeve. I always need hard sleeve. I need more of it. It's the hottest commodity on the rural fire scene, and I need to make sure I have enough of it. So I like to make sure that I over outfit my pumpers with hard sleeve, and I over outfit my tankers with hard sleeve, because realistically, aside from hauling water back and forth, the secondary job of a tanker is to support either the dump site engine or the fill site engine by bringing that equipment. So if I'm drafting, I want to make sure I have enough hard sleeve to do that. I want to make sure I have the right strainers for the areas that I'm dealing with. Some folks will just carry a low level strainer on their rig, and that might be okay, but I can't always use a low level strainer in every source, or I may not want to use a low level strainer in every source. Not to mention, a lot of them occlude flow. So having the right strainers and having the right tools and choices makes it easier for you on those rural fires to make sure that you can get water from wherever you need to get it from.
Bill, anything in your equipment cache that you can think of that we haven't mentioned yet that's essential if you're going to be for fill sites specifically?
Well, something he didn't mention, but he's a major component of, and that's the chafing block. It works out very well for, those chafing blocks are something when, it's one of the questions you have coming up when you're working by yourself. You may need that extra piece of equipment to help you out. Andy mentioned the strainers. Just everybody, please do your homework on your strainers. They are not all created equal. We won't get into which ones are better than others, but if you're not getting the flow that you feel you should be getting, it's probably going to be your strainer. That's my take on it. I love the manifold valves, the 4-way manifold valve, one from LDH into MDH. And then if you don't have that equipment, doesn't mean that you can't be an engine set up at a fill site. You just may need to run that off of your discharges themselves. All of the engines have 2.5-inch discharges, and you may have multiple of them. Use those if you don't have those different connections, and the operator can supply that water as needed when they're hooked up to the tankers.
One thing I want to mention, Bill mentioned the manifolds. One recommendation I have, if you're going out and purchasing manifolds, or even if you have them, be mindful and make sure you're getting and purchasing a manifold or a water thief or whatever you want to call it, make sure it has a relief valve on it, especially if we're using it for fill operations, because, we're going in those manifold controlled fill sites. We're going from filling a tanker at 1,000 gallons a minute to tankers overflowing, and we're shutting down the valves at the manifold. So now we're going from 1,000 GPM to 0 GPM, and that causes surges in pressure. And I want to make sure that I don't blow the supply line. The supply line's the weakest link. So having a manifold with a relief valve that will open up and relieve that pressure is a good thing. And it's what I want. So that way I don't have a catastrophic failure of another component and somebody gets hurt. Now, along, like Bill said, with the strainers, not all strainers are created equally. Not all relief valves on those manifolds are created equally. And what I mean by that is some are very, very user-friendly on the fire ground that I can adjust to make sure, because, depending on the scenario, the pump pressures are going to change, and I may need to reset that relief valve depending on how far the distance is and everything like that. Some are very easy to do that in the field. Some are not. So be familiar with how you need to set that relief valve, if you need to set that relief valve, and adjust from there.
Now, Bill, you get out and about. Andy, you do as well, but I'm going to start with Bill on this one. Besides this more traditional equipment that you just noticed in your travels, have you seen anything new? Some new innovations that you think departments maybe should look into, maybe, that they may not have heard of already? Is there anything out there that you think are like, you have to check this out? If you don't know about it already, check it out. Not saying it'll necessarily work for you, but at least, this is something brand new that hopefully will help you out.
So we've talked about it in the past. One of the things that a lot of departments, you'd be amazed at the departments that don't know about the turbo draft. That's a great tool for your rural fill site. That's you may not be able to get close to that water source because of rain or the terrain. You'd be amazed at the departments that don't know about the turbo draft, and it's a great tool for those fill sites. And using two of them, if you're looking, me and Andy's both been talking. We want to get 1,000 gallons a minute out of our fill site. Well, the turbo draft is rated around 750 gallons a minute, at its best. So we can use two of those instead of just the one. And when I say turbo draft, any type of a ductor, a system that way, there's multiple different brands. So those are the things that I really try to push on these departments that are setting up these fill sites.
Andy, how about you?
Well, one thing that I'm going to set Bill up for, because out of the two of us, he's the expert on this, but vacuum tankers. Bill, do you want to talk about vacuum tankers?
Yeah, vacuum tankers. They're not new either. They've been around since probably late 70s, but yeah, that's something that a lot of places don't know about. I didn't know about myself until I started coming to FDIC, and I ran into one of the manufacturer's owners, and I'm like, "What is this?" And yeah, vacuum tankers, they have the ability to draft over. You can draft up to 200 feet away. Your flow obviously gets lower, but at 100 feet away from the site, it will draft at 1,000 gallons. It also will dump at over 1,000 gallons a minute as well, consistently. Where the conventional tanker, when it gets below a half a tank, it slows way down. And then that last quarter tank seems to take forever to dump. Where a vacuum tanker dumps at 5 to 10 pounds above atmospheric pressure, so it has a constant flow until it's completely empty. So a 3,000 gallon tanker will consistently dump at 3 minutes. 3 minutes it's dumped, and it'll draft over 100 feet away at 1,000 gallons a minute as well.
Yeah, I mean, vacuum tankers are great technology. Like Bill said, they're not new, but they're new to a lot of people. But the thing here is, I love a conventional gravity dump tanker. It's what I grew up on. I'm not an expert on the vacuum tanker, but here's the problem with the conventional gravity dump tanker that the majority of the American Fire Service uses. It requires a lot of people and equipment to be filled, right? We're talking, this whole segment is talking about fill sites required for these gravity dump trucks, right? If we were to talk about fill sites for vacuum tankers, we would have been done in a minute on this podcast, because they're that efficient at the fill. They can be filled by one person who makes the connections, turns on that vacuum pump, and that thing just goes to work. So, if you are strapped for resources and don't have the manpower like we're talking about, that is a great tool to increase your efficiency. Something else that I have seen in my travels that I'm becoming a bigger proponent of and really, really like for these fill operations is hydraulically driven submersible pumping units. So essentially what you have is a trailer with a diesel motor mounted on it that powers a hydraulic pump that sends power to a submersible pump that you put into the water. And that little submersible pump will just pump and refill tankers. It can fill an engine or feed an engine. And it allows me to access water that, like the turbo draft, I couldn't have thought of getting to otherwise, right? But the beautiful thing about it is one person, again, can put that whole system into place. One person can fire it up and start feeding water. And if I have an engine, maybe I have an urban engine that doesn't carry hard sleeve, but they got to operate at this fill site on these larger scale incidents. Well, essentially all I've done with that submersible pump is I'm putting it in the water and creating a fire hydrant in that rural setting that urban engine can hook to and is being fed from, because it is in the water. It's pumping water to that engine or to those tankers to fill. So that's something that, I think is very advantageous. Maybe not every fire department needs one, but something on a regional level could be very helpful, to have a trailer with these submersible pumps.
One common theme among your answers to that question, and it's something that Bill did allude to a few minutes ago, was staffing. Having to perform some of these tasks maybe with one person. And you've talked a lot about this, Bill, where, when you're setting up these rigs, try to set them up so that one person, because we don't always know how many we're getting, one person can perform the tasks here. So with that in mind, besides what you've already mentioned, are there things that departments can do to optimize their equipment arsenal so that a fill site can get up and running with one firefighter? We mentioned the chafing block. That's something that's homegrown. Maybe there are some other homegrown things. Are there fittings out there that allow for faster make and break times for during fill operations, where one person can do all that? Bill, is there anything else that you haven't mentioned yet that we can think about, to make it more efficient for one person to do?
Yeah, one of the things is I take one compartment and I is dedicated to hose rolls. Instead of pulling off the back of an apparatus, it's easier for one firefighter to be able to grab the roll of hose and unroll it, and you're not going back and forth running to try to make these connections. You stand at that where you're going to make your first connection, you roll it towards either the apparatus or towards the manifold or appliance, and you just make that one connection without having to run back and forth. I always try to take everything that I do to the apparatus one person can do, and they don't have to run around the apparatus. Like we'll say, for instance, a rubber mallet. Make sure I have rubber mallets on both sides of the apparatus. I have spanner wrenches on all four corners of the apparatus. Those things can cut down on the time for one firefighter to be able to make these connections and get the system in play without needing a bunch of manpower.
Andy, anything on your end? You're out there training a lot. Are there anything that you recommend to these departments that you see to address like a staffing issue like that with just one person being on the rig?
I would say, as corny as it sounds, and we've alluded to it a bunch in this podcast and other podcasts, the pre-planning aspect, right? Going out, looking at these sources, identifying what challenges you have there, and knowing ahead of time, okay, if I have to go over, to the pond over here, right? I need to position the rig this way. I need to put, this many hard sleeve in the water, or there's a dry hydrant here. There's a turbo draft that I'm going to have to use, right? Whatever it may be, having that knowledge and having that information ahead of time and coming up with a game plan is going to simplify a lot of your problems. Now, by no means is it easy. That's a lot of work for rural organizations that may already have enough on their plate, but it will pay, mass dividends doing that work and identifying and coming up with a game plan ahead of time, right? Ideally, in my perfect world, if you're showing up to a fill site, hopefully that's not the first time you've seen that body of water. You know that water, right? Hopefully.
All right. Well, I like to always end these with a general comments kind of thing. Certainly, if there was one takeaway that you'd like people to have today, Bill, what would that takeaway be? Or if you don't have that, any just general comments about what we've talked about?
So when we're talking about firefighting, everyone thinks of the person on the nozzle. They get the glory. They're the ones putting the fire out. Understand that there are many jobs that need to be completed on the fire ground, and water movement and supply is one of those things. Take pride in what you do and be the best at supplying that water forward. One day you will be back on the nozzle, but if today your job is to supply water to that nozzle firefighter, don't try to figure it out right then and there. Be the best at it. Know what you're going to do prior to, and do it to the very best of your ability so that nozzle firefighter doesn't lose their water.
Andy, final thoughts?
Yeah, we're often taught that firefighting is a team sport, and it's very true. But rural water supply is the ultimate team sport in the fire service, right? So it takes a lot of different people from a lot of different places coming together to make it work. So my suggestion to the audience is, understand that the departments and the organizations that are successful with moving rural water and moving water in the rural environment, they're organizations that routinely train and do drills on rural water supply and do shuttle operations as a region or as a county or however your organization is structured. My recommendation is do that training, whether it be annually, biannually, ideally quarterly, right? Have those training events where you're doing nothing but setting up a water shuttle and trying to maintain a particular flow. That's how you get good at this stuff. That's the only way you'll get good at this stuff.
All right. Well, again, my thanks to both Andy and Bill for taking some time out today to talk about this. One of the main mission of fire apparatus and emergency equipment is to provide you with information to help you make more informed purchasing decisions. So hopefully today we helped you out on the fill site end of this. Again, Andy is an author with us. He's Water Thievery is the name of the book, correct, Andy?
Yes, sir.
And that is available through us at Fire Engineering Books. So make sure you get out there. It's been a very popular book, and I'm sure much of what we talk about here is in there. If there are podcasts that we have not, or podcast topics that we haven't hit on yet, either here when we're talking about water delivery or overall, let me know. I'm at chris.mcclune@clarionevents.com. So again, my thanks to Andy and Bill for spending some time with me today. Have a good one, everybody, and stay safe. Thanks again, guys.
Thank you.
Thank you.
This podcast is brought to you by Toyn. Since 1942, Toyn has been building high-quality fire apparatus with a wide range of options that are customized for your unique needs. Toyn is built to take the call. To learn more, visit www.toyn.com.